Hi, Emma. You know what? I was like saying, I was like, Jonathan and Emma are going to join me, and here you guys are. There you go.
Of course.
Nice. Okay, let's do, so this one's similar to question number 1. Hopefully you guys can see my screen there.
Yep.
Okay, perfect. Okay. Okay, so this one, what they're doing is they're giving you a quadratic with a shaded region. So this one has a dotted line versus in your assignment, you guys have like a connected line. So there's a slight difference in a connected versus a dotted line. So what you're gonna start with for question 1 is you're gonna write the equation of a quadratic in vertex form, okay? Then you're gonna complete this as if it was a quadratic. So you're trying to get the equation of the quadratic first of all, okay? So you're gonna find what the vertex is, and on your assignment, I should have given it to you. So on this one, I'm assuming it's kind of like negative 0.75 and about negative 7.5. Okay, so that's my vertex I'm using. I'm just gonna write it a little clearer. Okay, so the point, my vertex, which is my P and Q, is negative 0.75, and my Q value is negative 7.5. So I'm also going to pick another point. So if the x-intercept is clear, you could use that, or you can use the y-intercept. So any point that is clear, use them for your x and y. So my x and y, I'll use as my y-intercept, which is 0 and negative 6. Okay, so once you have the vertex and one other point, plug it into your equation. So your x is negative 6. Your a is what you're trying to solve for. X is 0 minus my p, negative 0.75, squared plus my q, which is negative 7.5. And then you're just solving for a in this step. So negative 6 equals a. 0 plus 0.75 is positive 0.75 squared. And then you're going to square 0.75. Minus 7.5. Now we're going to bring this q value to the other side by adding 7.5 on both sides. So negative 6 plus 7.5 gives me 1.5. And then lastly, you always divide by your value within the brackets, your x minus p, to get it to the other side. So this is solving for a. And I get, you can change it to a fraction or you can write it as a decimal. I kind of prefer fractions because they're always more exact. So that's 8/3 equals a. So I just pressed math, enter, enter to convert the 2.666 repeating this number right here to a simplified fraction. So I got 8/3. Once you have the a value, you're going to write the equation with x and y blanks. And I'm also going to not write the equal sign, because that's going to become my inequality. You're either going to have a less than symbol or a greater than symbol. So these are your choices. You can have this, that, greater than or equal to, less than or equal to. So those are your choices for in between. So my a is 8/3. Then it's x plus 0.75, because I'm summarizing the two negatives, becomes positive. And my q value is negative 7.5. So once you have the equation, as you can see, I left a space where my equal sign is, because I need to figure out which is bigger. Is y bigger, or is the right side of the equation bigger? So what you do is you pick a point within the shaded region. So this is like a test point that you're picking. So I'm gonna pick a point like 0, 0. Your hands are okay. That's okay. Don't worry. Give me one sec, actually. There you go. He has this thing with dirty hands. It's like OCD now. Okay. So our point that I'm going to use is 0, 0 because it's within the shaded region. I always like to pick an easy point to substitute, and 0, 0 is the nicest one to substitute, of course. So my test point is 0, 0. You can pick anything as long as it's within that shaded region. So my y is 0 and my x is 0. So you're going to go 0. Is that bigger or smaller than 8 over 3, 0 plus 0.75 squared minus 7.5? So now I'm going to evaluate the right side of the equation. So I'm going to put that in my calculator by going 8 divided by 3. In brackets, 0 plus 0.75 squared minus 7.5. And I get that the whole right side is actually equal to -6. This whole thing is equal to -6. I'm just going to move this. And as you can see, the 0 is bigger than -6. So what you're going to do is go back to the equation and you're going to put the greater than symbol. Now, if this was a connected line, meaning if this graph had no dotted lines, I would have included the equal sign underneath there. But for my graph, since it doesn't include the actual quadratic line, then you just have a greater than symbol. So my answer is y is bigger than 8 over 3, x plus 0.75 squared minus 7.5. And then what you can do is if you want to check your answer, you can go to Desmos and put this in exactly how you see it and see if it gives you that. So I'll confirm this by just putting this in. So I would go to Desmos. So this is how I check my answer. Oops, nope.
Help me.
There you go. I think it was minus 7.5. There you go. So as you can see, I put this into my Desmos and you can see that it's a dotted line with that shaded region being above the quadratic part. So that's how I know that I did this properly. Okay, so whatever you do for that one, you should know if you got it right or wrong by checking with Desmos. Any questions with number 1? So it's all about just getting that equation in quadratic form, in vertex form, and then just using a test point to see which way the mouse should be facing. Which side is bigger? Is it the left side or the right side? Give me a thumbs up, guys, in the chat. So after each question, just tell me if you guys are okay or if you need more assistance with that one before I go on. Jonathan's good. Perfect. Okay, question number 2. So this one's about making the equation. So a little hint to you guys about your question is that you're gonna have to make sure they're all in the same units. So in this case, do you guys see how they're all in dollars? But if I had some of the amounts in cents and some of them in dollars, I would need to convert them all into dollars or all into cents. So make sure, a little hint, is you need to be consistent with the units, okay? So that's just something you guys need to look at for your question number 2. So then you create a legend. For question A, you want to create an equation that matches this. You're going to say that X can represent, let's see, movie admission with popcorn. Doesn't matter which variable you use to represent it. So movie admission plus popcorn will be letter X, and Y will represent the meal. So we want to write an inequality to represent the number of movies and meals that Janelle can afford with her entertainment budget. Well, we know that we're going to be spending $15 per movie plus popcorn admission, plus we're going to be spending $10 per meal. And we know that she has a budget of $120. So we have to spend less than or equal to $120. So we can actually spend $120, which is why I put the equal sign underneath that inequality sign. Okay, so less than or equal to 120 is what you're trying to write there for A. So that's your equation, okay? The next part, so this is what I want to see for full marks, is you need to create...
This one.
There you go. You need to create a legend for what your X and Y represent, and then just the equation, Jacob, the equation that matches it. Okay, so for part B, you're going to graph the solution. Graphing the solution is where you want to solve for Y and then put it into your calculator like a linear equation. You can also use Desmos to help you as well if you want to graph it to see where it actually exists. So I'm going to solve for Y. So I'm going to go 10Y is less than or equal to, I'm going to bring the 15 to the other side. So I'm going to bring this 15x to this side by making it the opposite symbol. So that means negative 15x plus 120. And then I'm going to divide everything by 10. Because my goal is to, if I'm going to use my graphing calculator, you always need y isolated. So you're going to have that y is less than or equal to negative 1.5x plus 12 if you put that, if you divide everything by 10. Okay, so what you want to do is now graph this linear equation right here in your graphing calculator. You're going to graph negative 1.5x plus 12 as your y1. Okay, so negative 1.5x plus 12. Okay, and then for your window, I would adjust your window depending on what they see, what you see here. This is the 12. The constant is always your y-intercept. So we know it's going to be going through the y-intercept at 12, and then it's going to be going down from there because it's a decreasing linear equation. So for my window, I'm going to make sure my x's go from 0 to, let's say, 10 for now. And then for my y's, I'm going to go from 0 to, let's go slightly higher than 12. Let's go up to 14. So the goal is that once you graph it, you should be able to see your x-intercept and your y-intercept. There's my x-intercept right there. I'm just trying to mark it off. I can't really, there you go. So there's my x-intercept around there. And then I can see using that window what the y-intercept is. That's what you need to include when you graph this, is include the x-intercept coordinates and your y-intercept coordinates, and then you know that you have a proper graph, okay? So to find your y-intercept, press trace 0, enter. So trace 0, enter. So I know that my y-intercept is 12. So I just press trace x equals 0, and then I press enter, and I got 12. And then that is what you want to actually plot. So I'm going to make my scale go up by 2, 4, 6, 8, 10, 12, 2s. So I'm going to plot point at the y-intercept of 12. And then I also want to find out what my x-intercept is. So my x-intercept, remember, you can go second trace, number 2 to actually solve for it. You can go to the left side of that x-intercept and then go to the right side of the x-intercept, and this is how you graphically find it. Mine is 8. So my x-intercept is 8, 0 in my instance. 2, 4, 6, 8. So I can plot a point at 8, 0. You can also do this algebraically. So whenever you're trying to find your x-intercept, you can replace y with 0 and just solve for x. So if I solve for x and isolate for x, it would give me also 8. Once you have that done, because it has an equal then symbol, you're going to connect these 2 points, okay? If it just had this symbol, remember, you would have a dotted line. But if it has a less than or equal to symbol, then you're going to have a connected line as if you were normally graphing a linear equation, okay? And lastly, you need to figure out, are you going to shade in this region, which is below the linear, or are you going to shade in this region, which is above the linear? Logically, I know it's going to be below because I can't, if it's above, that means that the equation is going to be greater than $120. So logically, it has to be this region, but you can always use a test point to confirm. Okay, so my test point that I could use could be like the point 2, 2. That's within the solution region right here. So if I plug in 2, 2, that would be my way of confirming that that is within the solution and that should be shaded. So you can go back to the inequality and you can plug in where x is 2. So you can go 15 times 2 plus 10 times 2. Is that less than or equal to $120? So that's what you want to check in your calculator. That's going to be 30 plus 20. Well, 30 plus 20 is 50, and that is less than or equal to $120. So I know that where my 2, 2 is, that should be solution that's shaded. So the reason I didn't shade in this region, guys, the reason I didn't shade in here or here or here is because X and Y are number of tickets that you can buy for the admission and number of meals you can buy. You can't have negatives and you can't have negative values, right? So you also can't really have decimal values. So that would be a restriction if they ask for it, but they're not, okay? So in this case, I only include the answers in quadrant number 1 for logical reasons, okay? So that is question number 2, get the equation, and then find your X and Y intercepts, connect them, and then decide which region should be shaded. You can also put that into your Desmos to see if that gives you the exact same picture, right? So that would be your way of confirming that. Any questions about that so far, guys? That's good. Jonathan's good. How are you, Yusuf? And don't forget, you don't always have to be good. If you guys have any questions, if you want something to be clarified, let me know. I don't want you guys going back or leaving here still being confused and not knowing how to do your assignment, okay? So I just want you being confident about it. Question number 3. So they want you to solve the inequality, and on your assignment, I just wanted you to pick 2 different methods. Now there's 3 methods total. There's one where you graph it and you look at what makes sense. Another one is the number line method, and the third one is it's called sign analysis. Okay, so there's a sign analysis method. The reason I kind of focus on sign analysis is because when you get to calculus, that's what is preferred, because you're not supposed to be using your calculator, your graphing calculator, once you get into certain courses in university. So they kind of show you other methods that will help you. So we're going to do A with one method and C with another method. Okay, so first of all, you need to bring everything to one side, and you need to make sure that 0.
Just try to close it.
No, you can't. So you can't make sure, you can't, you have to have 0 on one of the sides. So what I'm going to do is I'm going to bring the 10 over to the left side by subtracting 10x. And now it's going to be less than or equal to 0. Now I want to combine like terms. X squared minus 13x plus 6 is less than or equal to 0. Okay, so that's my quadratic that I would be trying to solve for. So then you could possibly, if this was a nice quadratic, you could possibly factor it, but I know it's not going to nicely factor. So I'm going to either use my quadratic formula or my graphing calculator to graph this one. So I'm going to do the graphical method. So x squared minus 13x plus 6. So go to your graphing calculator and you would graph this. X squared minus 13x plus 6. Change your window so that you could see it. So I'm going to include the standard window for this one, or use the standard window. Graph it. As you can see, I need a little bit more. It looks like this one. This one should be an upward facing parabola.
Push it. Push it.
Here you go. So this one, it looks like I need more of my x maxes. So instead of going to an x max of Jacob, meltdown's happening. I changed my my x max to go up to 20. No, you can't use that. You can't do that one. You can go up to here. Let me restore it. Sorry, guys. That one's not working, Jacob. Use another one. Use another one, please. Okay. So once you have the picture of it, find your x-intercepts. So that's what's really crucial with all these methods, is find your x-intercepts with the next few questions that we do, or in the next 2 questions that we do. So go second trace, number 2. You're going to go to the left side of that x-intercept. And then you're going to go to the right side of the x-intercept, press enter. No, it's not letting me do that. Meh. There you go. Okay. So second trace, number 2, left side enter, right side enter, and my x-intercept, you're going to have to press enter again. My first x-intercept is 0.479. So write that down. And that was positive, yeah, 479. The next one, second trace, find your next x-intercept, go to the left bound, right bound, enter, and I got 12.521. 12.521. Okay, so if you're doing the graphical method, what I'll do is I'll just sketch it for you guys, and this is how you kind of show your work and explain your answer. So I have 0.479 there and 12.521 here. Now they're asking for, when is the graph, when is the quadratic less than or equal to 0? This is below the x-axis. This section right here is the less than symbol, and the section here is the greater than symbol. So what I want is where the graph is below, and that exists between the 2 x-intercepts. So I need to say that my answer is going to be where x is greater than and equal to, because it has equal to in the actual, in the question. You're going to be greater than or equal to the first x-intercept, and less than and equal to 12.521. So whenever you're talking about the little hump area, it's always between the x-intercepts. So this is how you would write it. And then you'd say x is an element of real numbers. Okay, so that is the answer using the graphical method. So if you are doing the graphical method, tell me what window you used. For example, my window I used to see this was x went from -10, +10, and 1. And then my y scale went from -10, +20, up to 1. Okay, so that's the scale I used. Oh, actually, it should have been the opposite. Should have been this one's 20. This one's 20, and then this one stayed as 10. There you go. So once you have the window, you also want to say that because we're talking about the less than region, this is where the graph is below the x-axis. So just try to explain in words what you're seeing and why you're picking that region, okay? So that's how you get full marks for if you choose the graphical method. You just have to say, how are you getting your answer from just looking at the graph? So that's the graphical. Let's go to C and we'll do, let me see. Let's do, I do want to show you the other one too. So we'll do the sign analysis one. Okay, so I'm going to write out the equation. So this is C that I'm doing. I'm going to bring everything to one side. Ideally, you want your x squared to be positive. I always just prefer, it's just my method of doing it, is that I always prefer that the x squared is positive. So I'm going to bring these two guys to the right side. So I'm going to subtract x squared on both sides to get rid of that. And I'm going to add 5x on both sides to get 0 on the left side. So I have 3x squared minus x squared is 2x squared. Minus 18 plus 5 is negative 13x plus 20. So there's my quadratic that I'm using to solve. Again, you could try factoring it, or you could use the quadratic equation where a is equal to 2, b is equal to negative 13, and c is equal to positive 20. So I'm going to use the quadratic equation to solve for the x-intercepts. So I'm going to go negative 13 plus minus square root of b squared minus 4ac divided all by 2 times a. So you're going to get positive, negative, or positive 13 because of the 2 negatives becomes, and then I'm going to calculate the radicand value. So I got 9, which if you square root 9, you'll get 3. So it's going to be 13 plus 3 over 4. And I'm also going to have to solve for 13 minus 3 divided by 4. So this one's going to be 10 over 4, which simplifies to 5 over 2. And this one's going to be 16 over 4, which simplifies to 4. So my two x-intercepts are going to be 4 and 5 over 2. So once I find my two x-intercepts, I'm going to start, actually I'm going to do the number line, and then I'll repeat this using the sign analysis if you wanted to use it that way or do it that way. So the number line is where I would put the values on the number line. So 5 over 2 would be here, 4 over here. It doesn't really matter how you space it. I'm just giving myself room around it. And then I'm going to pick a test point before, middle, and after these x-intercepts. So a value that's less than 5.2, that would be easy to substitute, would be 0. A value between 5 over 2 and 4 would be 3. So I'll substitute 3 as well. And then a value greater than 4 could be like 5 or 6, doesn't really matter as long as it's greater than 4. And then you would plug it into your original question, or the easiest one to plug it into would probably be this form right here, this guy right there.
This one, cat and hat.
Okay, go to cat and hat then. Okay, so now I'm going to plug them into the 0. The 0 is less than 2x squared minus 13x plus 20 equation. So if I plug in 0, this is 0, this will be 0. So you're going to get that 0. Is it less than 20? Well, yes, it is. So we know that this right here is the solution in the region. This is an acceptable solution region right here. Now, to save you guys time, if you know that this outer piece is going to be a solution, then this also has to be a solution, this value that's greater than 4. So you'll have choices. It's either going to be the middle between the two x-intercepts or the outside pieces when it comes to quadratics. So if you get one end and not the other end, you probably made an error. Okay, so you can even test it out if you want to, but I know that greater than 4 will be a solution. And so your final answer, you need to write it as, it's kind of like a domain. It looks like a domain. You'd say that x is less than 5 over 2, so you're using the x-intercept to mark off that region. So where x is less than 5 over 2 and where x is greater than 4, XER, those are the solutions to this problem. And as you guys can see, we didn't have an equal sign underneath the inequality, so you should not have an equal sign underneath those answers either, okay? So you need to make sure that it corresponds to what the question's asking for. So that's my solution. If you wanted to do the sign analysis way, first you would have to factor. So this is sign analysis if you're curious on that one. So this is just doing the exact same question using another method, factoring. So factoring would be where I would factor it to be 2x, and I think it's like minus 5, yep, and then x minus 4. So I'm just double checking if that works. 2x, 10, 8, minus 5, yep, that works. Okay, so as you can see, I factored it, and it's still going to look the same except that the right side is factored. So this is the factored form, where 0 is less than the 2 factors. And then what you do is you write out the factors at the side. We have 2x minus 5 is one factor, x minus 4 is the other factor, and their product, meaning when you multiply them, gives you this, which is, we'll just leave it in factored form. You don't actually have to multiply them. And what we're going to do is split this into 3 regions. So we're going to create 3 columns afterwards where we use test points. We have to always pick a value that is less than the first x-intercept, between the 2 x-intercepts, and then greater than the x-intercept. So for the first one, I'm going to pick the same values that I did before. Remember, oh my gosh. He just closed my screen. You guys still there?
Stop.
My precious son, okay. My precious son just closed the computer screen. Let's move this away from me. Okay, so my x-intercepts, I'm going to use the same x-intercepts that I had before listed, so that's not changing. Can you guys see my screen? Because I can't. Let's see what's going on here. Okay, presenting. I'm going to stop presenting for just 1 sec, see if I can fix this. Thanks, buddy. Okay. There you go. Okay, so, sorry guys, back to it. So I factored it, have the factors to the side, then I'm using the test points that I had previously used for my number line, where I used 0, which was less than the first x-intercept, 3, which was between, and then greater than 5 or greater than 4, I'll use 5 or 6, doesn't really matter. So we're going to plug them in. And what matters here with sign analysis is what sign is it? Is it a positive sign or a negative sign for each of these? So if I plug in 0 for the first one, 2 times x, 2 times 0 minus 5 will give me a negative sign. If I plug in 0 into 0 minus 4, I get a negative sign. Stop flipping out, Jacob. What do you want? 2 negatives, the product of them. What would you like?
Happy.
I'm about to like throw candy at you. Would you like candy?
Okay.
Okay, there you go. You want a bar?
Happy.
Here's candy. There. That will give me a little bit of time. Okay. So the product of them is where you take two negatives from the sign and you multiply them, you'll get the product, meaning the sign of what you'll get for your final answer without having to do crazy calculations or without even having to refer to your calculator. Two negatives becomes a positive when you multiply them. Now we go on to the next one. 2 times 3 minus 5 is going to be 6 minus 5, which is a positive value. Then we have x minus 4, which is 3 minus 4. That's going to be negative. A positive and a negative gives me a negative answer. Okay? Oh my God, he's going to town here. He won. 2 times 5 minus 5 will give me 10 minus 5, which will be a positive answer. Then we have 5 minus 4, which will also be positive. Two positives, when you multiply them, give me a positive. Now, if you look back at your equation, they're saying, when is this part of the equation greater than, meaning the mouth is facing that? When is it greater than 0? Well, this is the greater than symbol. When it's greater than 0, that means it's positive. So when is the equation greater than 0? We know that it's going to occur when the graph is less than 5/2 and greater than 4, which is the same answer that we posted here. So just, that's what you kind of read out of there. From the sign analysis, you're reading that this is your answer. Where the graph is positive, meaning greater than 0, you get those sections because they're plus signs, okay? If they had the symbol reversed, like let's say they had this symbol right here, that means that 0 is greater. That would be that the middle part, this part would be the solution, but it's not, okay? So that is what you do to check. And that is it for question number 3. So I just showed you the 3 methods, so you can choose between sign analysis, the number line to show it, or graphically, as long as you explain kind of what you're seeing and how you're getting your answer.
Okay, candies.
Yeah, I see candies. Yeah, yeah, there you go. You won. He's just dancing here. Okay. And are there any questions? Sorry, that was disrupted a little bit all over the place. If you guys have any questions about that, so pick your methods, 1 method per question, up to you which one you want to use. Are you guys good? No questions for me, okay. Emma's good. Good for Jonathan. Sorry guys, thanks for sticking by me as I deal with a toddler, okay? Maybe no, we'll see. Okay, question number 4, thankfully the last one before this guy, before he's done his candy. So gotta finish this before he finishes his candy or we're in trouble. Okay, so question number 4, it says, for each of the following, give an inequality that has the given solution. So I try to pick something. So I try to pick ones that were similar to the ones in your assignment. So what you're looking for is creating a quadratic that matches the solution. So what I start by doing is I'm going to solve for the factors first. So I'm going to move the 1 over so it looks like a factor. So this would be x minus 1. So that's one factor that comes from x is less than 1. So you're kind of going backwards to recreate the quadratic that looks like this or gives you this. Same thing here with 10. If you bring it over to the side of the x, it's going to be x minus 10 is greater than 0.
2, 3.
Okay. So as you can see, I just brought the values over to the side of the x, and I got 2 factors. Now all you have to do is you just have to multiply the factors together or do FOIL with them, and that will get you back to the quadratic that could have given you these x-intercepts. So it's all about just getting the equation and then figuring out which symbol you should use, either the greater than or less than symbol. So when I FOIL these, I get x squared minus 10x minus x plus 10, okay? So I simplify this and I get minus 11x plus 10. Now you could graph this. When I graph this, I know I'm gonna have 2 solutions where it's 1 and 10, so I can graphically look at this. And we just want to figure out which way the mouse should be facing or which way we should have the facing areas. If you guys look, these two arms are going to be where the graph is above the x-axis. Above the x-axis means greater than 0. This part right here would be less than 0, okay? So I would put the greater than 0 symbol. Now, if you don't like that method, what you can do is just test out a value. Like pick a value from here, a test point, or here. So what is a value of x that is less than 1? Well, we can pick 0. 0 is less than 1.
Candy.
So then I'm going to plug it into the equation. I'm going to see which side the inequality should be at. So I'm going to plug in 0 for my test point. This will be 0, this will be 0, and this will be 10.
Candy.
Remember, we're comparing this to 0. Whenever we have a quadratic, it's always going to be compared to 0. So if we have the quadratic compared to 0, we know that the 10 is larger. So that means the mouth should be facing the quadratic equation and not the 0. And since it does not have equal signs, there's no equal signs underneath it, you should not have an equal sign in your quadratic either. So that is your final solution. So the quadratic, and then you're just saying, is it greater than or less than 0? That's all you have to pick, is use a test point to figure out which one makes sense for your solutions. That is it for question 4. You guys want to see another example of that, or are you guys good? So you can visually see that, or you can use a test point to see which one makes sense. Emma's good. You guys, any questions? Do you want me to do either D or C or A? Jonathan's good. Yusuf's good. Okay, guys. Thank you so much for being patient with me and this little bugger. Can you say thank you to them? Jacob, can you say thank you? He's into like candy face. Say thank you. Say thank you.
Thank you.
Okay. Thanks, guys, for joining me. I appreciate you guys putting up with us. Okay. Enjoy the rest of your week, and then get this assignment done. And there's only one more left after this one. One more. You can do it. Okay. See you guys.
Candy.
Yeah, look, candy. Yeah. Yeah, I see candy too.
1, 2,